Okay, now we're on page 41 of your workbook. We're going to look at some other types of lines. Find the slope of each line and compare. What is interesting about the slopes? So again, I'm going to let you go through and do that part as a classwork. So pause the video and mark up the lines here and figure out what each slope is, and then what do you notice about them? Think about that, and then we'll come back. So I found the slope of line 1 is negative 2/3, and the slope of line 2 is 3/2. So what that looks like, if I take those two numbers and multiply them together, I will actually get -1, right? So what that tells me is these lines are perpendicular. And if you look at your definition right here, they are perpendicular if they are negative reciprocal slopes. So you could have it set up this way, that you have 3/2 equals -1/3/2. We could do it that way, and double check what this is when we simplify it and find out if we do get I should have lines of 2 there, so let's do -2/3, I mean. So when we flip this around, we have a negative and a negative, right? So that becomes positive, and we get 3/2. So they are, in fact, equal. You can just notice kind of how this line 2 slope is a flip around, the reciprocal of line 1 slope, but it also has the opposite sign. You can also multiply the two slopes together. So if you have m1 times m2, that will always equal -1 if perpendicular. So we're going to say therefore perpendicular. You can kind of write that little symbol there. These 3 dots mean therefore. So you might say, well, I could tell that by looking at it. Well, you probably can. You can eyeball it, but it doesn't tell you for sure. And you'll need to prove it out algebraically. So again, make sure you jot down this definition. If you're not using the workbook printout and you have a notebook, that's fine, but just make sure you jot that down. So here we have example 3.20. Determine whether the given lines are perpendicular. Why or why not? Again, that's really important. You have to prove it out. You can't just say, yeah, I think so, and that's it. So we're going to look at the slopes and compare them for each line. For A, it's pretty much set up for you in slope intercept form already. Part B, you have to do a little work to know that one's set up for you also. So I'm just going to let you go ahead and try those, do those as classwork. And then I'll write out the answers, so see what you think, but just state why. So if you don't know how to do that yet, just write out in words, but I'll show you like the shortcut way with symbols. Okay, so if we look at these slopes, we have 4/3 and we have -4/3. If we were to multiply those together, we would not get -1, or we could also just say no, since m sub 1 does not equal -m sub 2, like it needs to, stated up above in the definition. Now we can look at the slopes of B. We have 7 and we have -1, 7, and yes, those, if I multiplied them together or looked at my little rule up there, it works. So therefore m sub 1 equals 1/m sub 2. So therefore they are perpendicular. Okay. I should say not perpendicular, so that we don't get confused with whether we're talking about the parallel lines or perpendicular lines. So that's it for this couple of problems here for like the concept. The next page we'll use is page 42, and that one's a little bit longer, so I'm going to stop here. You'll have plenty of practice in your electronic homework and your paper homeworks for these kind of things, so there wasn't too much classworks there and examples. Okay, so have a great day and look for the next video.